Well, I mean, okay, so before we get started, I think I also have to say thank you to everyone. I mean, from just a post, and we had a lot of people like showing interest in the class. We have people from across Africa. I can see in the comment section, I can see Ghana, I can see Zimbabwe, I can see Nigeria, I can see Burundi, Cameroon. I mean, Kenya, it's a whole lot. So I I really appreciate your time here. I mean, taking out time in the morning to join this class, it means a lot to us. So thank you so very much for joining the class. So we'll just get started properly, and I'll go ahead and share my screen. So we'll start with the class. So you can still if you are just joining us, you can just do a little bit of introduction in the chat box and just tell us your name and where you are joining from. So I would like to know if you could see my screen. If you can see my screen, you can just reply the chats. All right, can we see my screen? I need someone to say yes. So I'll just continue. All right. All right. Thank you. So we'll just get let me stop. Let me stop my video. All right. So once again, we welcome everyone from the Geospatial Hub. David Aremo. I'm representing the Geospatial Hub. So in today's session, we'll be walking through Python. So let's just dive in. So before we dive in, it would be nice for us to like know a little bit about the hub. So basically, we we noticed, especially in the African space, there's this gap. We noticed a skill gap, and we also noticed a learning gap. Sorry, hold on. I have to admit this person. All right. So we we noticed uh, all right, so we noticed a skill gap, and not just a skill gap, we also noticed a learning gap. All right, so welcome again, everyone that's just joining us. We just started the class properly, so you can just do a little bit of introduction in the chat box and tell us where you're joining from. So thank you once again for joining this session. So in this session we'll be walking through Python. I'm David Aremo and I'll be the host for this session. So before we start this session properly, I wanted to introduce the hub to us. So basically we noticed there's a gap, not just a skill gap, but there's a skill and learning gap from the from what the university offers and what the student actually really need to learn. And when these professionals to be get into the field, we realize they can't actually tax up with what the field basically requires. So we came in to fill the gap. So our vision is to create a nurturing community for geo professionals, and our mission is to provide these geo professionals with easily accessible skills, to meet up with international standards. So and I would like to also announce to us that we'll be launching our website very soon. So in the past, we've been using YouTube. We've been posting content on YouTube. Recently, we we did this remote sensing. So if you're into remote sensing, you might want to like check out this playlist. So we just try to demystify remote sensing for beginners, and it's cut across all levels. So it's a really interesting watch. So that's what we've been up to for a while now, just trying to post our content on YouTube. But now we'll be moving forward to launch our website because we could really do more beyond YouTube, and that's why we thought about launching our website. So a little bit about me. I introduced myself earlier. David Aremo, and my research interests are basically in emergency response, disaster risk reduction, and I have a keen focus in monitoring crop health with remote sensing. I graduated from a university in Nigeria, Obafemi Awolowo University. I studied surveying and geoinformatics. I currently work as the remote sensing engineer at a local company here in Nigeria. And if you want to reach out to me, here are my contact details. This is my email. On LinkedIn, you can search Arimo David, and on Twitter, Dave_vid. All right, so let me just update this. All right, so from the form response, we had 296 responses. That's why I started out thanking everyone. I mean, it's a lot of response, and thank you guys for taking out time to fill the form and also joining the class. All right, so we from the response, it's obvious a lot of a chunk of the people that filled the form are beginners with Python programming language, and actually that is our focus. People uh, from 269 people, we have 55% of them at beginners level, and we have about 24% just with 2% knowledge. So I mean, it's really great. So we really want to focus on, for this class, we'll be focusing on these first two bars, because those are our primary target for this class. I mean, people with 3, 4, and 5 are actually quite comfortable with Python. So let's just move into the business of the day. So now, why do we want to learn Python? So there are actually a lot of programming language out there, but why do we choose to learn Python? So for beginners, Python is really let me say the go-to programming language, because it's pretty easy to learn. It's one of the languages that is similar, is pretty close to human language, so you can actually understand it, and it also has this community. You could just Google strings, and you could just Google strings in Python, and you'd see a lot of resource, like a lot of helpful resource that you could actually work with. And also I mentioned the code readability, because it's very close to human language. It's the programming language that is closest to human language, so you can easily work around um, work around you can easily work around Python as a beginner. Then also it has a large standard library. It has like a plethora of libraries. We'll walk through some in this tutorial. And finally, it is free. So before we get into the program, I tend to ask people, why do you want to learn Python? Like, why? Do you want to learn Python because everybody's learning Python, or do you want to learn Python because you have something you want to address with Python? I mean, why is Python your choice? So I tend to ask that question to a lot of people. So and if I ask myself the question, for me, I wanted to learn Python because it helps me automate repeated tasks while I was still learning GIS and all of that. I mean, I just wanted to be able to do GIS without having any contact with the softwares we use, like QGIS or ArcGIS. I wanted to understand the what underpins all the geoprocessing we do. So then I'm sorry, I have to admit this person. All right, so I said I just wanted to understand everything that underpins geoprocessing. And I mean, sometimes okay, look at this post. I had this post on my LinkedIn some years back. So the post was talking about having a tax. So imagine in your local government, you're working for your local government in your country, and you have a tax. So your tax is to basically buffer a river, um, and clip houses that are prone to flooding within the buffer zone. So after you clip it, you export it out to a new shapefile. I mean, if you want to do this task, it's relatively easy when you're doing it for, let's say you're doing for just one local government and you're doing it for maybe just one time frame. So you're doing for probably just a week or a month. But now imagine you have to do this for your entire country, and you have to do it for the past 20 years. I mean, it is error prone if you're trying to do it alone, if you're trying to do it on your own without programming, and it is also time consuming. It takes a lot of time. So it gets, I mean, when you're doing repetitive tasks, it gets boring. But with simple lines of code, you realize you can actually carry this out and it won't even waste your time. So I started out learning ArcPy, and I just realized if I count how many lines we have here, we have 1, 2, 3, 4, 5, and 6 lines. So with 6 lines of code, you could actually create a buffer, and I mean it was quite fascinating to me. So just to so my own why of learning Python is to actually um, automate repeated and boring tasks. So you need to ask yourself, why do I want to learn Python? Like, is it because the world is moving towards automation? Is it because I want to like build a game? Is it because I want to develop a website? Is it because I want to go into machine learning? You just have to like have your why. So you have to like start with why. Then once you know why you want to learn Python, then you can like start Python properly. So please in your mind, just ask yourself, why do you want to learn Python, and pursue it. So it helps you to narrow down what you want to learn. I mean, Python has a lot of libraries, so you don't get to learn what you don't like necessarily need. For example, if you are into machine learning, you just need to learn like the basic stuff. And I mean, with the basics of Python, you can start programming. You can start running code using the skitlearn library. So you just have to ask yourself, why do I want to learn Python? And once you have your why, you can get started with learning Python. So in few minutes, we'll try to cover these topics. I sincerely hope we'll be able to cover the 5 points we highlighted. So let's just get started. So the very first thing is how to install Python. All right. So kindly mute if kindly mute your mic. Oladejo, kindly mute. I'm trying to mute you, and I really don't know what's happening. It's not muting. All right. So I would have to remove you from the call. If I can't remove you, if I can't mute you, so you can always rejoin the call. But kindly thank you very much. Um, Mashai, I really can't pronounce your name. I don't pronounce it wrongly, so pardon me for that. All right, so we'll be starting with the very first item, and that's how to install Python. All right, so if you want to install Python, what you want to do is to all right, so the very first item is how to install Python. So if you want to install Python, before we can like start working with Python on our machine, on your computer, probably your MacBook or your Windows or your Linux, you have to first have Python in your machine. So the first thing to do is to download Python. So if you want to download Python, you just go to python.org, then you put the /download, so you'll be able to like download Python. So now at the time of this recording, this is the version of Python that is available. So once you download this, you just hit the download button. I'm not going to do that right now because I previously installed Python. So once you hit this button, Python gets downloaded on your machine. So you can download for Windows, Linux, and Macs, and Mac OS. So once you do that, you can start, once you do that, then you install it on your system. So once you install it on your system, you can start, you can actually start coding even with your notebook, like with a notepad. You can start coding with notepad. You can start coding with there's something we call IDE. IDE are basically it stands for Integrated Development Environment. So you can actually start coding with any IDE if you have Python running on your computer. So, Python, like we mentioned earlier, it has a lot of libraries, right? So it depends. It has some dependencies if you want like run some modules and stuff like that. So for this particular tutorial, we'll be using Anaconda. So I find Anaconda quite interesting because it has all the basic modules we'll be running with. So we don't need to start installing them or something like that, except we need extended functions. So if we want to get Anaconda running on our computer, so we go to we just type Anaconda. So you can just Google Anaconda download, and if you Google Anaconda download, but the website for it is anaconda.com, and once you go there, you see you choose either you want to download for Mac, you want to download for Windows or Linux, and so once you have it on your computer, you can start running your codes. So this is my Anaconda navigator. So I've installed it, and this is what it looks like on my system. So would start we'll start it up, and we'll see what the interface looks like. So starting up, depending on the speed of your machine, it starts up faster or slower. So those that are just joining us, welcome again to the class. We've been trying to discuss about the class so far. We started with the hub. The hub is basically the Geospatial Hub is basically a bridge. It basically bridges the skill and knowledge gap between geospatial professionals, because we realize the geoprofessionals the universities are like producing are not actually, they are basically lacking the skill and the knowledge that a geoprofessional should have. So basically, that is why we started the hub, and we are on YouTube. We've been having some videos in the past. We recently concluded the live session called Demystifying Remote Sensing. So if you're into remote sensing, you can just go to our YouTube. On YouTube, you just search the Geospatial Hub. You find us, and you can go to our videos and see our playlist, and you can start learning. So basically, we are trying to bridge that learning and knowledge gap, and also we'll be launching our website pretty soon. So we'll send you guys emails once we launch the website. All right. So we are. Hey, good morning. Thank you. Um, yes, I am. Yes, I am. Yeah, thank you very much. So we'll be sending the link to the recorded session. The recorded session will be up on our YouTube, so you can always watch the recorded session. All right, so this is what the Anaconda Navigator looks like. So it has so many tools you could actually install, and I've installed the useful ones. So we'll be using Jupyter Notebook. So you just want to launch Jupyter Notebook. So you hit the launch button, and it basically starts up. So we'll just navigate to a particular folder we want to work with. So all right, so I'll just use this particular folder. So now in this folder, we can create a new folder to store our scripts. You just come to new, and you can, but I don't create a new folder, since I created this particular folder for this particular session. So I'll just click on Python 3. and then it opens Jupyter Notebook for me. So this is what Jupyter Notebook looks like. So let's just walk through the interface in a bit. So now we have the file. This is like the normal file we have to open a new notebook. All this, you can also, if you've written a lot of code, you can also like download your code as any of these formats. You can use the edit button. You can, once we start coding, we'll get familiarized with all of these cells, and we might not even necessarily have to use all of these cells. I'll talk about the shortcuts to them. So you can see the shortcuts here, X, C, and all of that. So we'll just basically be using that. We have to insert a cell, and you want to clear what is in the cell, or you want to do something. So these are like, this is basically what the interface looks like. You want to save, you want to insert a cell below. So, and I particularly like this this aspect of the interface, the code and the markdown. So let's just talk about what markdown is. So markdown is somewhat like a rich text format. So and I like it because if you want to code, it just gives this kind of heading format to our code. So if you want to write in markdown, there's a link I have here. So this link talks about different syntax for markdown. So we'll just talk about a few of them. So if you want to write something in markdown, you can just write hello and welcome. So that is how a markdown looks like. The interpreter, the Python doesn't really like the Jupyter Notebook doesn't it doesn't read it as a code. It's a markdown, and it's basically to just give description to what we are doing. For example, if you want to comment in a fancy way. So I said in a fancy way because we can just use some syntax to make it look more fancy. So if we use the hashtag, we have to use like the double hashtag, and we can have our first heading. So this can be something like heading 1. So if I run this, you see, sorry, let me just confirm is one hashtag. All right. So heading 1 is actually one hashtag. So if I have something like this, you see it gets bigger, and if I want to like format it further, I can have double hashtag, and this will be something like heading 2. If I have this, it can be heading 3. So if I want to give points, I can just start with this is the first point. So if I run this, it basically just makes our code looks neater. So that is what the markdown is. And if you want to, if you look at the markdown option, instead of having to come here every other time to switch from code to markdown, I can always use the shortcut, the keyboard shortcut I was talking about earlier. So you want to come outside of the cell, and if you want to have a markdown, you just want to press M outside of the cell. So once you press M, it changes to a markdown, and that is how we like automatically switch to markdowns. So I'll just change it back to code, and now we can start coding. So we can just have the simple 1 plus 1, just arithmetic. And if you want to, instead of having to come here to press run every other time, I'll just be using the shift enter. So shift enter, you can use enter basically, but I use shift enter because it comes down to a new cell, and it's really easier for me to work that way. So that's just a brief overview of working with the interface. If you come to the help, there's a user interface store, so you could always like tour the interface when you are free. All right, so let's start with the very agenda of the day. So we've covered how to install Python and Anaconda. We've also covered the notebook interface. So now let's start with variables. So now if we want to start with variables, I can just come outside the cell, press M. You have to like come outside the cell, then you see the cell is marked blue, then you press M. So once you press M, now you want to give it a title we are talking about. So we are talking about variables. So we're talking about variables. So now before we get to talk about variables in Python, what are variables? Variables are basically containers. They're kind of old stuff for us in Python. And in Python, when we want to return something to the screen, we use the keyword, we use this function print. So we can print hello. This is like the simplest code everyone does, hello world. So once you press shift enter, it returns hello world to the screen because of this print function we used. So now we want to talk about variables, but before we get to talk about variables, let us just print fancy stuff on our screen. So let's print hello, I am David. I'll just copy this because I want to replicate it a lot of times. So I want to just tell you a little bit about myself. Hello, I am David. I am 176 centimeter tall. And let's just have one more details about me. My favorite color is black. All right, so if we run this, okay, this is meant to be a V, sorry about that. So if you run this, it says, hello, I'm David, I am 170 centimeter tall, my favorite color is black. So this is just a simple print statement working. But now imagine we want to have this story, this story, we want to have this story. So imagine we want to have this story about someone else. So let me just pick someone, from the all right, so let's say we want to have this story about Muhammad. So we always have to manually come here and change we always have to come here and tweak what we have in the print statement. So I can say Muhammad. Now let's say Muhammad is 200 centimeter tall, and now let's say Muhammad's favorite color is blue. So I have to always manually come here to do that. So if we want to do something else for, let's say, a lady this time around, and the lady's name is Mary. So we always have to come here, say Mary, and let's say Mary is 150 centimeter tall, and now let's say Mary's favorite color is pink. So we always have to like manually change it. So now this is where variables come in. So variables are like containers, right? So these containers can actually store the values of different items for us. So now instead of always having to change Mary, change the height, and change the color, we can have these values, Mary, the height, and this color, we can have it stored in a container. So now that container is what we call our variable. So the container are the variables. So now I'll just make a little bit of tweak and show us how we can have variables in our statements. So now we can say, let's say name. Let's just have name. So now we can say name is equals to now whatever we want as name. So let's say a new person, let's say John. So we can say the name of the person is John. We can have the height. So let's say height. So we can say the height is, let's leave it at 200. And finally, we can have color. And now we can have the color as blue. All right, now, so anytime we want to change what we have, we don't always have to come in the print statements to start changing all of this. So that is where variables come in. Variables are like containers, placeholders. They are holding the values of whatever we want to change. So imagine we have this is just like a 3-line. This is just a 3-line text. So imagine if we have like 1,000 words. I mean, it will be very difficult to go through the 1,000 word and start looking for Mary or the 150 or the pink. So now we can replace Mary. So we can just erase the value of Mary here, and now we can have name. So if I run this, it automatically replaces this name with John because it's a variable, it's a container. It's basically holding the value of of John. So if I run this now, it says hello, I'm John. So instead of having to like look for where the name is in our where the name is in our statement, we can always come here to tweak and have the variable. So that I was just trying to stress that, so we explain what variable is. So here we have the 150. I can cancel that and have something like I can have the height. So I just copy this and paste it here, and all right, and also similarly I can have the same thing for the color. So that is the usefulness of variables. I just wanted to tell us about variable. So now the next thing we want to talk about is assignment versus assertion. All right, so again, let's use the markdown. So now you have to come here, press M. So you just say all right. So now what we've done here, when we said name is equals to John, what we've done is we've actually assigned this name John. We've assigned John to this variable name. So anywhere we call name, it returns John. So let me just print. So let's just print just the name. So it basically returns John. So now what we've done earlier is an assignment. We basically assigned this value John to this variable name. So anytime we want to assign a value to a variable, we use the equals to sign. So we use this equal to. So that's the assignment symbol. So if I want to assign something, I can just say s is equals to. So now I can write I love GIS, for example. So now anytime I want to get the value of s, I just use the print statement, and when I print s, it returns I love GIS, because we've used this equals to sign to assign this value I love GIS to s. So now I'll just print s, and it returns I love GIS. So that is the assignment symbol, the assignment operator. We are assigning a value to a variable. So I've been assigning just strings. So you could also assign integers. It does not necessarily have to be strings. So if I print height as well. So one thing about Jupyter Notebook is you could always use the tab to autocomplete. So if I print height, it returns the value of height that we've stored in height. So let me just accept this person. All right. So that is assignment. But now when we are trying to assert, we use the double equal sign. So we are trying to assert something. So we are trying to say this thing is. So let's say and it's basically used in when we are trying to compare something. So we can have num1. So let's say num1 is equals to 100, and we can also have num2. So let's say num2 is 100 as well. So now we can try to assert the value of num1 and num2. Is num1 actually num2? So we can say num1. Now we are trying to assert. Now we use the double equal sign, and we can say num1, num2. So now if we run this, it should return a true or false if num1 is actually num2. If num1 and num2 are basically equal, so it returns true. So that's just the difference between assignment and assertion. I took out time to explain this because I realized there been a lot of confusion between when we have the equals to and when we have the double equals to. So we'll talk more about this in the class. So I think my pace is a little bit slow, so I'll try to move faster, so we'll be able to cover other aspects of this course. So now we'll be talking about Python data types, and we'll also learn about mutable data types and immutable data types. So as a beginner, I would advise we listen carefully to this particular session, because most of what we do in Python are basically built on different data types. So we've been working with some data types all along, but I haven't mentioned them. For example, when we started with the very first line of code we wrote, we started with an integer. So okay. So integers are basically numbers on the number line. So if you have something like here we had num1, and now num1 we assigned it to 100. Here we have num2, we said num2 is also 100. Here we have s is equals to I love GIS. So this I love GIS is in quotes. So anything in quotes in Python are strings. So we'll be talking about let me just list the data types we'll be talking about. So the very first data type we'll be talking about is integers. So after integers, we'll mention floats, floating point numbers. So after floats, we'll talk about lists. So after lists, we'll talk about dictionaries, and after dictionaries, we'll talk about tuples. So these are like the most popular data types we use in Python. And for us that we are interested in in GIS, this will really be important. So if you want to declare a variable as integer, so you just have any variable. So let's say num1. So we can say num1 is equals to 100 like we did earlier. So now you want to know what data type is num1. So we use the print statement, and now we print. So we use the keyword type, and now we have our number, which is num1, into the brackets. And now once we run this, it's telling us that this is an integer class number. So basically that is what the integers look like. So when we want to declare integers, we just have numbers on the number line from, I mean, whole numbers are integers, like from it could be any number basically on the number line. Now when we want to declare floats, we can say num2 is equals, so floating point numbers are numbers that have decimal points in them. So any numbers with decimal points, it could be positive, it could be negative. So if I say print, now I want to print the type of num2, so I want to print the type, so we say print type, and we use the autocomplete, which is the tab. So you want to autocomplete your text in Jupyter Notebook, you use tab, and now I say num2. So now if I press shift and enter, it runs, and now it tells us that this is the float. I'm moving very fast because we're actually against time. The class is for an hour, and I want us to cover everything and even still ask questions. So that is how we declare floats. And now the next thing we'll be talking about is lists. So now in Python we have it's actually good to comment our codes. So when we comment our code, it basically gives it more readability. You know, we're talking about why Python earlier, and we're talking about the fact that it's actually very readable. So to like tell users what your code are doing or what your code is doing, you use the hashtag. So when you use the hashtag, Python does not read whatever comes after the hashtag. So you're just trying to tell the reader or the user of the code that yeah, we are talking about integer. So I can say integer int declaration or something. So it is just basically to give end users like an idea about what you're doing. So anything after this hashtag we will not run. All right, so yeah, it's for floats, so I'll just have it as floats. And now we want to talk about lists. All right, so for lists, okay, so before we talk about lists, I skipped one very important part, and sorry about that, and that's strings. Sorry about that. So yeah, before we move to lists, we'll just talk about strings. So now if you want the cell above, like I mentioned earlier, you just click the cell outside and you press A. So A basically creates a new cell above. So now we'll be talking about strings. So basically we've been using strings so far since the beginning the code. So now where anything you see in quotes, anything you see in quotes are string, right? So to declare a string, the string syntax is if you want to declare a string, we use single quotes. We can use single quotes to declare a string. Let me just comment this. We can use single quotes to declare a string. We can use double quotes to declare a string, and we can also use triple quotes to declare a string. So a question that might be coming to your mind right now is, why do I need to like use single, double, or triple quotes? So basically, I would say it depends on, when we are talking about GIS, we have methods in GIS. So it basically depends on the method you're familiar with, or the procedure your firm uses. So anyone you're comfortable with is fine. But there are some unique cases where we have to use probably single quotes, double quotes, or triple quotes. So let's talk about when we want to use the single quote. So we can just have a string, and we are saying s is equals to, so I would say something simple. I love GIS. And now if you print the value of s, it returns I love GIS. It returns it without the quotes. Now if I change this and I use the double quotes, it still works. It still returns I love GIS. But in some cases, you want to ask a question. For example, let's just ask a simple question. Isn't that the girl? So now this is a simple string, and it's in double quotes, but I don't want to use double quotes. I want to use the single quotes. So I want to explain why we need to use single quotes in some cases and why we need to use double quotes in some cases. Now, if you want to write this, normally there's meant to be an apostrophe here. And now if I include this, now Python understands strings in quotes. Now we are given these three different quotes. This one quote here, this another quote here, this another quote here. So when the interpreter is reading this, he reads this from year to year as a string, and this, it throws it off as an error because it doesn't understand why we are having like triple quotes. So let's just run this and you see the error. So it's saying the syntax is invalid. So now this is the cases where we get to understand why we need to use double quotes or single quotes or triple quotes. So now if you run this in double quotes, now Python is going to understand because everything within the double quotes is seen as a string. So now if you run this, it basically runs without error. And now you could still use the single quotes if you like. I mean, if it's your company policy to always use single quotes. Now Python provides escape characters we could use. So if you want to like escape a particular character, you just use the backslash, and it prints without error. So this backslash basically ignores whatever you have like after the code. Now when do we use this triple quotes? Now majority of us on this call, we have a GIS background, and we know with GIS, when we are trying to write coordinates of a place, we use degree, minutes, and second. So in cases where we have I always forget how to write this. All right, I always forget how to write this degree symbol, so most of the time I just Google it. Okay, so alt plus 0176. All right, so let's say we have something like so let's say we have latitude, and the latitude of a place is, let's say 3 degree. Okay, so now we have to press the alt 176. It's not producing the degree here. Oh my. I don't know why it's not producing the degree. Okay, I'm missing the 0. Sorry about that. Alt 0176. I really don't know why it's not responding. Let me try one more time. Okay, you can try it. You can try it on your computer. But in cases where you have strange symbols, right, that Python might not understand. So let's just put the dollar sign. So let's say 7 minutes and let's say 11 seconds. So now if you look at this particular if you look at this particular sorry, please pardon the degree. The degree is meant to be sorry, pardon the dollar rather. The dollar is meant to be in degrees, but I can't really pull up the degree. So now when we are declaring strings, we declare strings with now when we are declaring strings, we declare strings with either single quotes, double quotes, and now in this particular coordinates, we have both single quotes and double quotes. So that is where the triple quote comes in. So if you want to have a string and you have the single and double quotes in it, so that's when we use the triple quotes. So now I can just copy this, and whatever is inside the triple quotes is taken as a string. So if I paste this here and I just return the value of lat, it gives us this. So basically that is where the triple quote comes in. So now if you want to declare anything as a string, anything at all, if you want to declare it as a string, so you use the single quote, use the double quote, or use the triple quote. So that is how we declare strings. And the next thing we want to talk about is the lists. So now lists in Python, lists are basically containers. It basically, so now we spoke about integers, floats, and strings. So now list is like a container. It can actually hold multiple values. So sometimes when we are working as GIS people, we want to iterate over some values, and now it won't be easy if you have those values just stored out as plain text. But if you have those values in a list, it will be like easier for us to like iterate over them. So that is where list comes in. So for this list, let's just call it our shopping list. So I'll just use the name shopping something. This is just a variable. It could be like anything. So now if you want to declare a list, you use the square brackets. So we use the square brackets and the items in the list. So we could have apples. So after the first item, you use a comma. So after apples, say you're shopping for maybe you want bread, you want some breads or something. And now like I mentioned earlier, list could actually hold any of our data type. It does not necessarily have to be strings alone. So let me just put some random numbers and also let me just have a float. So basically, if you want the values in this, if you want to return this list, all we have to do is to just print shopping. And once you print shopping, it returns the item in the list to us. So this is how we declare a list. So there are actually different operations we could actually perform on all of these data types I've mentioned earlier. So let's say let's say for the integers, floats, strings, and lists, there are like different operations we could actually perform on them, but time won't permit us to talk about those operations. So we'll just like quickly rush through all of the data types. Then in coming sections, we can talk about those operations we perform on all of these data types. So the next one we want to discuss about is the dictionary. So now I'll just make a comment and say dictionary. So now, dictionary is kind of similar to list, but it kind of gives us a means to have like a key and a value. So what do I mean by that? So let me just say my dictionary. So so my dictionary, and now for my dictionary, if you want to declare a dictionary, you use the curly brackets. So I mentioned key earlier and I mentioned a value. So now you give it a key and give it a value. So let's say the very first key is name. Now what is the value in the name? So I'll just say David. Now, let's say the next item is age. So I'll just say age, and what do you want the age to be? So let's say 13. And now you could give it, you could like populate it, you could like just keep on populating it. Now you could just call your dictionary and you say my dict, and now once you run this, it returns the values in the dictionary. So the syntax goes thus: you have the key and you have the value. So these two are like key and value pair. So if you want to declare, you start with the curly brackets. If it's for list, you start with square brackets, but for dictionaries, you start with curly brackets. You give it the name and you use this colon, and you give it the key, and you write the colon, then you give the value. So earlier, while we were talking about variables, I just remembered we were meant to talk about something we didn't talk about. So I'll briefly just highlight that. So if you are declaring variables, there are some rules to declaring. There are some rules to declaring variables. Like we can't start variables with numbers. You cannot start a variable with, let's say, first name. You can't start something like this. So if this first name is equals to David, if I run this, it's going to throw an error. So it's saying invalid syntax, right? So you cannot start naming a variable with a number. So also you cannot have spaces when you are naming variables. So let's say something like this. So say first name. Now we want to write the first name properly. So let's say first name, and now if you have David, if you run this, it's also going to throw an error. The syntax is also invalid because we cannot have spaces. So there are different ways to like name our variables. So people use camel casing, but I would just advise us for code readability, I advise us to use underscore. So if you noticed, I remember we didn't talk about this naming variables because I use the underscore here. So I remember we skipped that. So whenever you are trying to like name your variable, it's just preferable to use underscore instead of using any other naming format. If you are comfortable with other naming formats, you could also use that as well. But I will just go with the underscore. So now, once we just say first name, so it basically stores, and now it returns David. So that's another rule. And also it's also noteworthy to mention that Python is case sensitive. So if I have something like this, age is equals to 13, and I want to get the value of age, so I print. So if I print now, I'm printing age with a capital A. So if I run this, it's going to throw an error. So it's saying name error. So it's telling us that age is not defined. So Python is case sensitive. You cannot, in any occasion, tweak the variable name. The variable name has to be constant. If you are using small a, you have to keep up with the small a. So if you want to correct this, you just change it, and you have the small a, and now once you run it, it basically runs. So the last thing we'll be talking about this variable naming is you cannot start naming your variable with any of this syntax. Basically, you cannot start naming your variable with this. It won't fly. It won't work. So you don't name your variables with that. So now back to, we are really pressed for time. It's almost 11. So now the last data type we'll be talking about is tuple. Some people call them tuple, some people call them tuple. So I'll just go ahead and declare a tuple. So if you say something like, so tuple are kind of similar with lists, but they are not mutable. You cannot change the content of the tuple. You can change the content of a list. I remember that I was going to talk about mutable and immutable data types. We'll talk about that shortly. So now so for tuples, so I'll just say my tuple. So now if you want to declare a tuple, you use the parentheses. So you want to have this, and now you can also take different values. It can take the string, can take the floating point numbers, and it can take the integers. So I'll just have 1, 2, 3, just to keep it simple. So now if I if I print the data type, so I want to know what type, what's the data type of my tuple. So if I do this, it runs and returns class tuple. So that is how we know, okay, this is a tuple. Similarly for the dictionary, we could also have something like this. So instead of returning the dictionary, we could also have something that tells us what is the data type of the dictionary. So it returns, let me just use the print statement. So it returns that this is a class dictionary. So the same thing, we can do the same thing for the shopping. We can also, I think, okay, we've done the same thing for the floating and the integers. So all right. So real quick, I just want us to very fast run through run through Python operators. So let me just copy this. So now, once we run through Python operators, I'll just mention the mutable data types and the immutable data types to us as well. So now we have integers, floats, string, list, dictionary, and tuples. So there are a lot of operations we do with all of these data types, and so for us to do any of these operations, we need Python operators. So we have a plethora of Python operators. So the very first one we'll run through is the arithmetic operator. So for the arithmetic operator, we won't like waste much of our time there. So we have the plus, we have the subtraction, we have the multiplication, we have the division, we have the floor division, we have the modulus, and finally we have the power. So let's just do something real quick. So now remember we had num1 earlier. So our num1 was 100. So we could say num1 plus num1. So if we do this, it's 200. Now we can now assign this value of 200 into a new number. So let's just call this num3. Remember, no spaces. So now if we run this, and now it is not returning any result because we didn't tell it to return any result. So now we can say print, and we can say we should print the value of num3. And once we run this, now num3, now 200 is saved into num3. So those are our arithmetic operators. So now we could use different, we could use the subtraction, we could use any of this. Like, it's pretty simple to use any of this. So I'll just explain this last 4. So now let's have 10 divided by 3. So now if you have 10 divided by 3, it gives us 3.3333. Now the difference between this division and this floor division is the fact that the floor division does not give us all of these remainders. It just gives us the value we want. It just gives us the whole number, the integer part. It doesn't include the floating part. So if we run this, we get 3. Now the modulus, this modulus is basically, it returns the remainder. So now if you change this to the modulus sign, it returns the remainder. So now once 10 divides 3, the remainder is 1. So it's returning the remainder. And finally, the power. So if you have the double asterisk and we have 10 raised to the power 2, let's just use 2. So it gives 100. So that is the arithmetic operator. So someone wants to join the call. All right, so that is the arithmetic operator. So now real quick, we'll move on to comparison operator. So now for the comparison operator, we have the less than, we have the greater than, we have the less than or equals to, we have the greater than and equals to, we have the double equals to, and we have the and we have the not equals to. So this comparison operator, it basically, when we use this comparison operators, it basically returns true or false. So we can have 10 less than 100, 10 less than 199, it returns true. Now if you have 10 greater than 199, it returns false. Now we can have less than or equals to, okay, let's have 10 greater than or equals to, it should return a false. Now, sorry, that was meant to be an equal sign, so it should return a false. Now if you use the double equals to, it should return a false too, but this double equals to would be what I would use to explain the mutable and the immutable data type to us. So if you want not equals to, you just change this and you have that, so it should return true. So those are like the comparison operators. So now the next thing is the identity of operators, and now this is where I want you to pay all of your attention. Like I need you to pay all of your attention. Identity operators. So now for the identity operators, we have is and we have not. We have is and we have not. So those are like the two identity operators. So let's have num1. We have num1 as 100, and let's have num2. Let's say num2 is 100 as well. Num2 is 100. So now to use this identity operator, we just use the simple print statement, and we say print. So now we want to know if num1 is num2. So once we print this, it returns true. All right, so now let us have a list, right? Let us have a list L1, and let's say L1 is equals to okay, before we have a list, before we have this list, let us have a print statement using this comparison operator. Let's have num1 is double equals to num2. So once we have this, it returns true. So both are returning true. So now let us have a list. So let's say L1 is equals to 1, 2, 3, and now let us have another list. Let's say L2. Let's say L2 is equals to the same thing, 1, 2, 3. And now once we run this, it runs. Now let us use the comparison operator and let us compare the identity operator and the comparison operators. So now please, I really need you to like listen properly here. So now let us print L1 is equals to L2. So it returns true. Now let us say L1. Now is L1 L2. It returns false. Like why are we having false here when we use the identity operator is, and when you use the comparison operator, it returns true. And this is for the list. But when we're working with integers, it returned true. And when we use the identity operator, it returns true. And when we use the comparison operator here, it returns false. It also returns true. So why are we having this difference? What is basically something must be wrong somewhere. Like this is returning true, this is also returning true. But when we used it here, one is returning true and the other is returning false. So now this is where we get to talk about mutable and immutable data types. So we have some data type, we call them mutable because we can change the values that are stored in them. And now the immutable data type, we cannot change the values that are stored in them. So for example, string, I just want to diverge a little bit. Strings are immutable. So if I have S and I say S is equals, okay, we have S earlier. I think S was, isn't that the girl? Now I can say S again is equals to GIS. So now if I run this, and remember, strings are immutable data type. We cannot change the value. We cannot change the items in the string. So now if I run this, it returns GIS. But earlier I said strings are immutable. So why is S returning as, isn't that the girl here? And S is also returning as GIS here. And I said we cannot change the values in. And I mentioned we cannot change the values in a string, right? So there's this function I want to introduce to us. It's called ID. So now the ID function, it prints the memory location of whatever we have like our variable. It prints the memory location of these variables in our computer. So now I just want to add this, and I want to copy this. Now I was talking about strings being immutable, right? Now, oh my god. So sorry about that. Now I was talking about strings being immutable. Now the fact that we have S here and S is returning isn't that the girl, and we also have S here is returning GIS, is actually invalidating what I just said about strings being immutable. But how do we determine if a data type is mutable or immutable? We determine if a data type is mutable or if it's immutable by the memory location. We basically try to compare where our computer is storing that data type. Now, if we can change the values of that data type in the same memory location, then we say it is mutable. But if we cannot change the we cannot change the values of that data type in the same memory location, then we say it is immutable. So now let us just print the memory location. So let us just have this one more time. So now we are saying S is this, S is this, isn't that the girl? And now we also, so let us just print S as well. Now instead of having this twice, we can merge the print statements as one. So I'll just add a comma and I'll say S. So now let's run this. Now look at the memory location. Now let us run this. Look at the memory location. So now this is proving that strings are actually immutable data type because we cannot change the same, we cannot change this value of GIS and we cannot change this value of isn't that the girl in the same memory location. So far we cannot change these values in the same memory location, then this is a immutable data type. Now going back to this list, we would also print. Now, going back to this list, we would also print the memory locations of the items in the list. So now, let us just. So now, what this comparison operator is doing, it is basically comparing the values we have in L1. Now, the value we have in L1 is 1, 2, and 3. It is comparing what we have. Remember, when we talk about the comparison operator, yeah, I told you it basically returns true or false when it compares what we have. So now, what it's doing is comparing what we have on the left-hand side, which is L1, and what we have on the right-hand side, which is L2. So L1 is equal to L2, so it returns true. But now, this identity operator, it is not comparing what we have on the right-hand side to what we have on the left-hand side. It is comparing the memory location of what we have on the right-hand side to the memory location of what we have on the left-hand side. So now, if it compares the memory location and those memory locations are not equal, it returns false. So now, once it returns false, it is proving that I'm getting a lot of. Okay, so I lost my train of thought there, but before we continue, let us just print the memory location of. So if you want to print the memory location, use the ID, you use the keyword ID. Let us print the memory location of L1, and we also print the memory location of L2. So now, if you look at these two memory locations, they are actually in this Python has actually stored L1 in this memory location on my computer, and it stored the value of L2 in this memory location on my computer. So now that is why when we use the identity operator L1 and L2, when we compare them, it is returning false. So I just wanted to stress the difference between this comparison operator and the identity operator. I hope we understand this identity operator. So the identity operator does not just compare what we have on the left hand side with the right hand side as we have with the comparison operator. It compares the memory location. Now let us change the value of L1. Let us add 4. Now if you run this code, this is definitely going to return false because we have 4 here and we don't have 4 here. Now you'd see that L1 would maintain this same memory location once I run this cell. Just notice L1 will maintain this memory location once I run this cell. So now let me run this. This should return true. Okay, this will return a false. And now once I return this, L1 should maintain the same memory location because we've changed the value and this memory location is not changing. This memory location for L1 is not changing. So it is proving that L1 is actually a mutable data set. You can change the values in L1. Now for tuples, we mentioned tuples earlier. Now for tuples, we cannot change these values. If I sorry. Now this is our tuple, right? Okay, so let me just talk about some method, right? So we can have quick one. We can have something like append. So let's append a value. Let's say 5. So now if you run, let's just add a cell below. Let's just add a cell below. And now let's say L1. So now I'm really getting disturbed with all of these things. I have to accept. Sorry, kindly mute your call. Kindly mute, and someone is Akinremi, kindly mute, please. Thank you very much for that. All right, so going back to our code. All right, so let's have something like this. So we have let me just cancel this and run the code again. So now let's have our L1. So let's say so I don't want to talk about method in this class, but just to explain what I need to explain, I would say L1. Now we want to append a value to L1. So let's just say L1 dot append. So when you want to use the method with your data type, you use the dot. So now once you say dot, you can now write what you want to. You can now write the method. So once you use the append method, so I'll use the tab to autocomplete. Now I want to append 5 to the list. So now if I print L1, now L1 has updated. So now I can update the values in L1. Now look at this again. Just take note of this memory location. I want to print the value. I want to print this L1 again. Let me just print this again. You'd see that the memory location did not change despite the fact that we have appended a value. So if you have let's change the value to 58. Now if I print this again, you'll notice that this is not changing regardless of how many regardless of the tweaks I have on L1, the memory location it's saving is not changing. So that is proving to us that lists are actually mutable data type. You can change the values in a list. But now for our tuple we had earlier, so if I have a new cell and I told you tuples are immutable data type. So now if I say my tuple, and now we want to say use the same append function, it will just throw off an error. So let's append 4. So it said tuple object has no attribute append. So we cannot use all these methods. We cannot change the data types we have in our tuple. So that is what I was trying to explain with the mutable and the immutable data types. Then one more thing I forgot to mention. So when we are working with all of these integers, floats, we can always call the help function if we need help. Like if you are trying to struggle to remember a particular method or something, we can just so let me just have a new cell. Let's just do it for this dictionary. So we can just call help. So if we say help, and now you can have like your dictionary inside it. So now it gives you different methods and functions you can actually use with the dictionary. But we'll talk about this. But if you want to like just see the functions you could use with the dictionary directly, so you can just use the keyword dir, and now you put the keyword dic. So you can use this. You can use this for any of the data type. You can just type help and you put any of the data type. So maybe in when we have another when we have a similar class to this, we can like talk about all of this. But for this class, that's not our goal. So we're actually 15 minutes past 11. So I'm sorry for expending more of our time. So now we've talked about identity. We stopped at identity operators. Now another operator we'll be talking about is the assignment operator. So now we'll wrap up very soon. I'm sorry for taking our time this much. So now for the assignments operator, we mentioned a few earlier. The key, if we want to assign something, so we use this symbol. So we use the equals to. We can also use the plus. You can also use the plus equals to. You can use the minus equals to. You can use the multiplication equals to, and you can also use the division equals to. All right, so these are like the syntax. These are like the operators of the assignment operator. So now if we have if you want to assign, we spoke extensively about assigning earlier. I think that's one of the the topics we started with. So I will not deliberate much on assignment operators anymore, but just for people that joined late. So if you're trying to assign something to if you're trying to assign an object or anything to a variable, so you just call the variable name. So we can just say name, and now we want to assign something. So let's say we want to assign this string David. We want to assign it to a name. So now you say David, which is the string. Now you use the assignment symbol, which is the equals to. So now you want to assign David to something. So you can just say let's say user. So now whenever we need to call David, we just call user, and user returns the value of David. So now if I just print, if I say print user, it returns David. So we've actually assigned David, we've assigned the value of David to user. So that is how we use the assignment operator. So now maybe we have a number. So let's say num1 again is 100, and now we want to just write a quick code to increase the value of num1 by 5. So normally we just say something like this: num1 is equals to num1 plus, let's say, 5. So now if we run this and we print num1 it should return 105. But now this is where the assignment operator like comes in handy. It kind of gives us like a shorter way to write this. So instead of having having to write all this again, we can just have plus equals to 5. So now once we run this, and now we run this again, it still gives 105. So just to make sure this is working, I'll change this to 100. So now I'll run this cell again, and I'll run the cell, it will return 200. So that is how we use the assignment operator. So now one more operator we'll be talking about is the logical operators. So for the logical operator, the keyword and, we use and, we use or, and or. So those are like the two operators. So we can say something very simple. So let's just print let's say 10 is equals to 10, and 20 is not equals to 50. So now if you run this, it should return true. So basically what this and does is that it compares what we have on the right hand side to what we have on the left hand side. If both returns true. If this is true and this is true, then it returns a true. But if one of them is false, so if you have 11 here, so if one of them is false, so it basically reads this will return a false and this will return a true. And when we are using this logical operator and, if one of them is false, it basically returns false. So if you run this, it returns false. But now if you change this keyword to all just needs one of this left hand side or right hand side to be true. So all will return as a true. So now the last operator we'll be talking about is the membership operator. I'll wrap it up with the membership operator. So the membership operator, we have the keyword in and we have the keyword not in. So let's just print okay, let's have S again. Let's say S is I love GIS. And now once we run this, it runs. Now we want to check if we have a particular value in S. So we can say, we can check, so we can say print, so let's say GIS. So we want to know if the value GIS is in S. So we just use the keyword, in, then we write S. So this should return true. Now remember I mentioned earlier that Python is case sensitive. Now if you say love, and now I'm using the capital L, here. Now if I run this, it will say false, basically because Python is case sensitive. Now instead of having in here, if I have not in and I run this, it's going to return true. So those are like the 6 operators we'll be talking about in this section. And with that, I believe we've wrapped up the topics we want to cover in this short training. So finally, the full content of this course, this is just like a preamble to the course. The full content will be on our website, and we have some of the contents also on our YouTube, though they are basically unlisted. We've not listed it to the public yet, but we'll do that in a bit. So we've covered how to install Python Anaconda, the Jupyter notebook walkthrough, Python variables, and all of this. So we'll just populate all of this on our website as well, and we would appreciate it if you join the website and also subscribe to our YouTube channel. So just for us to wrap up, do we have questions? Do you have questions? Just before we wrap up, if you have questions, hello. Once we launch the website, you'll be able to get certificates on the website, definitely. Yes. All right, thank you. All right, next question, please. Hello, good morning. Definitely, I can do that. We have textbooks that are like tailored to geospatial professionals and tailored to just Python, with Python for geospatial professionals. So we can also attach that to the mail once we like send a follow-up mail. Yeah, thank you. Hello, good morning. No, no. All right, thank you for your question. So earlier I was trying to, I don't know if you joined early or you joined late. All right, cool. So we spoke about this string syntax. So if you are trying to declare anything as a string, you can either use the single quotes or use the double quotes or use the triple quotes. So I'll be using the single quote because I'm I'm kind of more convenient using the single. It's kind of more convenient using the single quotes for me. You could also use the double quotes. You could use the triple quote. So I was explaining that with this earlier. So imagine I have a single quote here and I run this. It basically still runs. Now let me change this to the double quotes. And I run this cell again. It basically still runs. It still returns this is integer, right? But I was trying to explain some peculiarities where we get to use the single quotes or the double quotes. For example, if you want to have an apostrophe here and you are using the single quotes, it's going to return an error because Python would not understand why we are having 3 quotes. Normally in Python, you have to encode your strings. Now, this is an encode string already. This I, S, and N. Now, Python does not understand why we are having another quote here. So now, if I run this, it's going to return an error. So now, to bridge this, you can actually use the double quotes, right? You can use the double quotes. Now, if I run this using the double quotes, it works. Also, if you don't want to use the double quote, if you're like me and you like sticking with single quotes, now you can still use the single quotes. Python provides an escape character that basically ignores whatever we write after the escape character. So the escape character is backslash. So now once we run this, it still works, right? It doesn't return any error. Now, when we want to use the triple quotes, I was trying to explain the triple quotes as GIS professionals. We work with, let's say, longitude, latitude, and want to represent lat and long. We use degree, minutes, and second. So earlier, I was trying to get how we like get the degree symbol. So but I was unable to like get the degree symbol. So now for the degree symbol, imagine this dollar sign was a degree symbol. So now look at this. Now it has this particular latitude, it has the single quotes, it has the double quotes, and now it has a foreign language, it has a foreign symbol as well, and we want to make this a string. Now that is where triple quote comes in. So the triple quote basically covers for cases where we have, like in this case, we have just a single quote. Now the triple quote covers where we have even double quote or single quotes. Now once we are declaring integers, we don't need to have them in quotes. Now if you declare this, now look at this. Now if I put this in quotes, it will work. But now once you print the type will change to a string, because anytime Python says anything in quotes, it just automatically assumes is a string. So now let's run this. Can you say change to class string? But once you are declaring integers, integers or floating numbers, you do not need to put the quotes. Now if I run this cell again, it changes to class int. So I hope that answers your question. Yeah, so let's just take 2 more questions, then wrap up. Thank you. Oh, all right. So if I would recommend a laptop for GIS, I would recommend the RAM should be at least 8 gig. If you have an external screen, you don't need a big screen. But if you don't have an external screen, you can use 15, at least 15 inches. Then the processor should be at least, let's say 2.4. So it will make your processes faster. So if you have those basic requirements, and this is not so compulsory, but it makes it seamless as well. If you have a graphics card, so if your graphics card is about anything above 1 gig, it also works fine. So those are like the requirements for a GIS system, in my own opinion. So let's take one more. Yeah, sure. So let's take one more question. One more question. Hello. Hello, please go ahead with your question. Sorry? Oh, string formatting. All right. All right, just because it's the last question, I would accommodate that. String. All right, so string formatting. All right, so remember, if you want to make this a markdown, you don't necessarily have to come here. So you just come outside the cell and press an M. So we'll be talking about string formatting briefly. So you want to, okay, I thought someone was requesting. All right, so we have num1, and we have num1 as, okay, let's say we have num1 as 100, and we have num2 as say 200, and I want to print something with num1 and num2. Or I even feel like explaining string formatting with our very first variable declaration. We could also use this to explain string formatting, but let me just go with the simple one first, then we can come back to that. All right, so now if I run this cell, you want to say, so now I want to print, normally, so far we've been doing something like this, print num1, then we get the value of num1, but it's not really cool this way. We can have something like this, so let's just have a string, and we can have, say, this is the value of num1. So now if you do this, sorry about that. So now it's telling me, I appreciate the fact that I have this error. It's telling me invalid syntax because I did not format my string properly. So now that is where the string formatting comes in. Now, if I want to format the string properly, what I need to do is just have a comma here. And now if I run this, it says this is the value of num1. So this is a very basic string formatting. But now I can choose to include, instead of having num1 here, so just look at this. So I can say the value of now I use this, right? I use this curly brackets, right? And I just bear with me. You might not understand why I'm using this curly bracket, but once you print our statement, you would understand why we're having this curly bracket. So I can say the value of, now I'm having this curly bracket. Now whatever I want to be in this curly bracket, right, would be immediately inside a format. It would be immediately inside the format. So I can now use the dot. Now I write the keyword format. So now what do I want to be inside that curly bracket? So I want num2 to be there. So I can say num2. So I can say the value of num2 is, so now if I print this, it is going to replace what we have in num2 here into this curly bracket. So I can just run this, and now it says the value of num2 is 200. So this is basically string formatting. Actually, this is one old method of string formatting. There are newer, there are actually different method of string formatting. This is the one I enjoy the most. You could use, for example, if you want to concatenate. I don't want us to go like deep into it because that's not what we like planned for this session. But if you want to concatenate, we can also use string formatting. And there's a new format. I think it's called the F format. So this F format, basically, you don't need to have this format keyword. So this F basically replaces the format, and now you can have everything you want, in your string. And now inside here, I'll just have num2. So if I run this, it still works. So these are like different ways. Remember the previous one, we had the format outside, but now the modern way to like format string is to not have the S outside, the F outside, and just have this F in the beginning. And the previous, there was this very old form of string formatting whereby you have the I think the percent sign and some. I've lost track of that because I've not used that in a very long time. So I just use the dot format. But one thing about Python is that you would always have to Google. You would always have to Google because I mean you run through errors. So you can just Google string formatting and you'd see you see a lot of them. You see the new string formatting, you see the old string formatting, and you see all of that. So basically you can just Google, but not just to waste our time. I hope I have been able to answer that question on string formatting. All right, guys. So thank you very much for your time. So we would really appreciate it if you follow us on all of our social media platforms. On Twitter, you can follow us at the Geospatial Hub. The Geospatial Hub. On the same thing on LinkedIn, you can also follow us, the Geospatial Hub. And we would also appreciate it if you follow us on YouTube. YouTube is where we basically post majority of our content. Just on YouTube, just search the Geospatial Hub and you find that. And also, if you want to follow me, I tweet a lot about GIS, remote sensing, and Python. This is my handle, Dave_vid. You can follow me as well, and also on LinkedIn, you can also follow me on LinkedIn, and this is my LinkedIn profile. And thank you again, everyone, for this session. I appreciate your time, and that will be all for this session. Bye for now, everyone. Yeah, thank you. Thank you. Thank you.